All right, everybody. Good afternoon. Thank you for coming to our CCI Corporate Partners Program Tech Talk presented by one of our corporate partners, Lutron. This is Shemesh, and he's going to be presenting the Tech Talk today. So Tomer is also an alum. He graduated in 2017, so still fairly recent, and so I'm glad to have him back as an alum and as one of our corporate partners.
Awesome. So yeah, hi everyone. My name is Tomer. I work at Lutron. I'm a senior project software engineer, and with me I have brought
Swizzle. I also work at Lutron. I'm a project software engineer. Been with Lutron for like around a year. I work on the cloud teams. I work with some of our host integration partners like Alexa and Google and things like that.
Yeah, and I work on the mobile app team on Android and iOS. So who is Lutron? In case you haven't heard. So Lutron, we are a lighting control and smart home company. So we make things like lights, shades, thermostat, speakers that you can all control from your phone. And then we also do a whole bunch of third-party integrations. You connect our smart home with all your other smart home things like your Nest, Sonos, like I just said, Siri, Alexa, all of that stuff. And we have a whole list of third-party integrations that you can connect our system to. And we also have mobile apps for Android and iOS, so you can control all of your devices via your phone. So, why does Lutron care about mobile app security? And it's because our app is used to control our devices, and when users go and buy Lutron devices and put them and install them in their house, they're expecting that they're going to work every time, and also it's going to be secure. Nobody wants to go and install a light switch in their house, only to learn that someone else with an app, 100 miles away, can turn their lights on and off, by some exploit that they've found in the app. So, I'll be skipping the setup process of a lot of the tools that I'm going to be showing just because they're pretty tedious and long to set up, but I've left links in the speaker notes of every slide where I reference something, so you can go back afterwards. There'll be a link to the slide deck and you can go view all the tools in more detail, learn how to use them, and do the tutorials and things. It's also a pretty technical talk. I've tried to keep it a little bit high level, but if you need some basic knowledge of programming to kind of understand some of the concepts. But I've tried to go in and talk about everything that I didn't think you guys would know. And also, I do love animated GIFs, so hopefully that's okay with you guys. So, during this presentation, I want to talk about 4 main attack vectors that I think a lot of people who are in the security industry, these are the 4 things they think of when they think of, I'm going to start reverse engineering or hacking an app. What should I do? Where should I start? So, the first thing, network request interception. So, with most mobile apps that you have, if it's communicating with the server, usually the phone is sending data between the server, and the server is sending back to the data back to the phone. So this could be like the Facebook app, right? It's sending you your profile data, you're sending your statuses, all this kind of information. And a lot of people, when they're using this kind of technology, they don't realize that when you're using an app to send data to a server, it's not private. Many people think just the app and the server can see it, the transmission, but this can actually be seen and modified by a user in real time. So how does this work? So as you can see, usually before you just have a phone and it's connected to a server, everything's hunky-dory, everything's secure. But there are certain programs we can get that allow us to send all our phone's traffic through a computer before going to the server. So what this means is that basically we can open up a program like this, and here you can see an example of what it might look like when I'm sending traffic through my computer. So I can see all of the requests it's making, all of the JSON information and data it's sending, all of the header information, and all this really detailed things. But that's not where it ends, right? I can also write scripts in this program to modify the requests as they're getting sent out. So I can write a script that says, okay, you see this argument foo1 right here. I can write a script that say, whenever you see this argument foo1, instead of saying bar1, I want you to send something else entirely. And I can just modify things on the fly as they're going. I can also do things like repeat requests. If I capture a request of something happening, I can just click it and click send 100 times, and it will just send the same request 100 different times, which can be used for a bunch of things. So let's look at some real-world examples of how this might be used to compromise an app. So the first thing, and I see this all of the time, specifically because people don't realize that anyone can see the data. So let's take an example you might have a dating app, right? And you're swiping through and you see someone, and you see their name is Tomer and they're 3 miles away. But the server is actually sending their full name, their actual latitude and longitude, their Facebook ID, and all this personal identifiable information. And this is no bueno. You can't send information like this. Anyone can see it, and it's a horrible data leak. And it's not just things like data apps. Like, there are tons of apps that are just sending information that they really shouldn't be. You should always assume whatever you're sending, anyone can see, and you should only send exactly what you need. Another example, so let's say we want to modify an outgoing request. So let's say you've made a game, and every time someone finishes the game, you want to send a request to the server to say, hey, this person just finished, and their score was, whatever it was. So I can write this script to say, oh, when you're sending out, replace the score value with whatever I want, and then just send, 9999, and this way I can just make you think that I've just, had a new world record in your game just by modifying the outgoing requests. Similarly with incoming requests, let's say when I log in, the server sends to me my information and whether I'm a pro user or not. And maybe when I'm a pro user, this unlocks extra features in the app, lets me do extra things. So normally this value would be false, but while it's coming to the phone, I can write a script to just replace this with the value true, and then all of a sudden I have access and abilities in the app that I definitely shouldn't have. So it's very powerful, and some other use cases, things like bypassing validation. Say you're only checking if an email is valid on the phone, and then just accepting it on the server, right? I can just enter in a valid email, send it, and then when the request is in the air, I can change it to something invalid. I can also do things like I said before, replay attacks. Let's say, whenever someone watches an ad in your app, you want to give them $5 in-game dollars. Well, maybe I just watch an ad, see that request go out, and then I can just send that request 100 different times, and you start thinking, oh, he just watched 100 ads, so I'll just give him all this, in-game currency. Another example is making requests that you definitely shouldn't have access to. So let's say you have a request for getting a friend, and you pass the user ID to get that friend. Sometimes people would just assume that because the app is sending the request that it's already been verified, that user 10 is my friend, but because I can just rewrite these values on the fly, I can start requesting friend number 112. And who knows if that friend is actually my friend. You need to make sure that on the server side, you're actually checking all of these things and saying, when this person is requesting this data, do they actually have the permissions to be getting this data? I shouldn't just be assuming that because it came from the app, it's correct. So that's wrapping up on the network request interception. So the next thing I want to talk about is decompiling apps. So what is app decompilation? This is the process of taking an already compiled app. So usually, you write your source code, you click run, and it generates this kind of package, and you run this package on devices. And most people think, there's no way to go backwards from that compiled package back into source code. But every day, decompilers are getting better, they're getting cheaper, they're getting easier to use. And what this does is take your compiled package and use software to generate, not one-to-one, it won't generate your source code, but it'll generate a readable version of your source code where people can look through and see how your app works, what are you doing, what securities do you have in place. And especially on Android, they have decompilers that I'll show you later that will pretty much almost give you a one-to-one copy of exactly what you put on the Play Store. And most people I talk to who do app development don't even know this is possible. When I tell them you can decompile App Store apps, they have no idea because once you have an app on the App Store, it doesn't seem obvious that you'd be able to pull that out of the App Store in any way. Think of the Apple App Store. How would you even go about pulling an app off of that? It doesn't really, it's not an obvious thing that you would be able to do. But there are decompilers, so they have something called APK tool for Android. As I said, it's very robust. This will give you a one-to-one, almost one-to-one copy of what your code looks like, assuming you haven't done any extra security things. It'll also dump all your assets in your app you have, any images, any files, any hard-coded strings, or anything like that. And they even have an online version. So you don't need to have anything on your computer. You can literally just go to a website, type in an app, and it'll basically just download the source code for that app, or the decompiled code for that app. Similarly with iOS, it is more difficult to decompile an app on iOS, and there are tools for it, but it's definitely still doable. And it definitely will still, you can still kind of walk through the code and see what's happening. So yeah, users who usually have a jailbroken or rooted phone, this is where it starts. You have an already modified phone, so you install the app on your phone, and then using your jailbroken phone, you pull the app back off, run it through a decompiler, And then, as I said, you can look through it, see how it works. It's also a great way, if you're hard coding any passwords, any keys, any certificates, all that stuff is super easy to pull back out once you've decompiled it. So let's take an example of what it might look like when I decompile some code. So I've written an extremely simple app here, and I kind of wanted to show you an example of a naive way of encrypting network traffic. So let's say, right, my example from before from Charles, where you can inspect network traffic. I just decided I'll just encrypt all my JSONs, and that way people who are watching will have no idea what I'm sending. So I've just written this code, and as you can see, all it does is when the user logs in, it generates this JSON with the username and password, and then it just calls encrypt JSON, which loads up this file called mySuperSecureKey, and then just does an AES encryption to encrypt the JSON with that key, and then it sends it along the way. So let's pop this into an app, and then pull it back out and decompile it. And as you can see, it kind of looks like the exact same thing. Nothing here has changed. You still have all the original methods, all of the code is pretty much the same. Sure, the stuff isn't exactly the same, but I don't think it takes a genius to look back through this and know exactly what's happening and be able to just do it yourself. So with Android apps, a lot of people think they can just use ProGuard, and what ProGuard is the built-in obfuscator in Android Studio and Android, and it basically is just like a switch you can flip that lets you like secure your code. And some people think like, oh, that's fine, I'll just turn that on and it'll make all of this impossible to do. But if we go ahead and compile this with ProGuard and then decompile it, you can see that all it really does is change the method names and the variable names. So this is, it's so-so. It's definitely better than we had before. It's definitely harder to follow, but it's still, I can still follow this and just look through and see what code is being run and how it's being run. So the next topic is runtime memory manipulation. So what this is basically, with the jailbroken or rooted phone, I can go get an app from the App Store, running an app, and I can use a tool to inject a custom debugger while the app is running. And what this lets me do is, one, it lets me dump all of the class variable and method names from your views and from your objects. It lets you view those objects that you have in your app and manipulate them in real time while the app is running. It also lets you call arbitrary methods within the app's code, and it lets you modify the file system, which are all very, very powerful things. So to do this, we're going to be using a tool called Flex. So Flex is an in-app debugging and memory manipulation tool. Basically, it's a jailbroken tool that you install on your phone, and it can be injected into any app during runtime. So you start up the app, you triple tap the status bar, and this little window pops up. And from here, you have a whole bunch of options of things you can do on the running app. So let's once again take an example. So I built this very, very simple iPhone app here. As you can see, all it does is display whether a user is a pro user or not. And it does this by checking this function is pro user, which just returns false. So basically, this should never have the pro user be true. It should basically be impossible. So first, let's take a look at some memory manipulation. Now, if we go ahead and trigger Flex while this is running, we can see that we get the label up that's being displayed, as well as the function for checking if a user is a pro user. So with some runtime memory manipulation, we can go ahead and click on that view. We can then see all the properties that view has. And then once we have that, we can simply click on any of the properties, see the property, and then change it in real time. So even though it should say is pro user or whatever, I can just change this to be whatever I want. And it's also important to note that this is not just applicable to views. This is applicable to any objects you have in your code. So anything you have, someone can just open this up, view the objects, and just browse through the memory map of the app and just change whatever they want on the fly. In addition, let's say we had this method is pro user. So I want to show that you can just call whatever method you want. So if we click on this is pro user, we can just call this and just see what it returns. And this is a great way of reverse engineering things. Whenever you want to go through and see what methods you're doing or how they're working, you can just go there and just call them and see how they work and see what they return. And this is very powerful, lets you do a lot of things, and lets you see really in depth how the app is working, how the memory is working, all the methods that the app has. In addition, this can also modify persistent data. It's not just for modifying the memory of the app. So you can go ahead and you can modify any databases you have in the app, any user defaults you have, any preferences you have, you can just go in and change them willy-nilly. So if you're just saving, a score or a value or anything inside a database on the app, anyone can go in and change that. It's not a secure place to store things. And the last main kind of topic of security is method swizzling. And this is where the really, really powerful stuff happens. This is where like super advanced, things can happen. This will give you basically total control of an app. Before you were kind of just doing things that already existed. You were modifying requests, modifying memory, trying to like change things a little bit. But this is where the power comes. So once we know the methods and the properties that a class has, we can actually inject our own code into the app to replace these methods. So when it goes to call a method within the code, we can reroute that to our own code and do whatever we want. And once we're in there, we can run code as if we would any other way. We can call the methods within the code, we can modify the variables within the code, we can do new things, add new features. And this is all using an open source library called Theos, which lets you write your own code and then compile it right onto the phone. So let's see an example of this. So we'll take our example from before, and we see we have this method isProUser. We can go ahead and write this very simple hook right here. We can say, I want to hook into the method Swizzle example, I want to hook into the class viewController, and I want to override the method isProUser, and then I want to return true. So instead of, whenever this code is called, instead of calling the regular apps code, they'll go ahead and run mine instead. As you can see, after doing that, isProUser is true. And now I've basically root access into the app, and I can run my own code, and I can do whatever I want. So, yeah. It doesn't end here, though, because once I've gone ahead and written my own code that can be injected into the app, Theos actually lets you take those changes, compile it back into the app, and then you can distribute this modified app to other people, even who aren't jailbroken. So this is very common. This is called sideloading. What people will do is they'll go in, they'll hack apps, and then once they're hacked, they'll give it to other people, and then this is now this is their entire websites and platforms devoted specifically for marketing and having modified apps. So they're just websites, and you'll see like YouTube++ and Phantom for Snapchat and Spotify++, and all these things are people who have written their own code that have been injected into the app to do things like disable ads, add features, download videos and photos from Snapchat without other people knowing, and it's become an entire marketplace. And there are hundreds and hundreds of apps where people have just modified them and re-uploaded them for other people to use. And you might be wondering, how do you protect yourself? That all sounds very scary. There's a lot of things you can do. You can basically get root access to any app you want. What am I going to do now? So the first thing you can do is have a strong server. So the thing about your code running on someone else's phone is it's just that. Everything's running on the client. So no matter what you do, no matter how much security you put in, no matter what you do, the client can always be compromised, can always be hacked, can always be modified. So what your goal should be is to have an extremely strong server, so that way you can try and keep hacked clients contained. So if someone is able to hack the app, you don't want that kind of exploit to propagate to other people. If someone is hacking a game, you don't want that to be able to hack the game and then get into a game with other people or things like that. So your main goal should always be, if someone's hacking a client, you should be able to stop it on the back end and stop that from being propagated to other people. That being said, though, there are a whole bunch of other things that you can do within the app to make it more secure and much harder to reverse engineer. So this is kind of a big list. I'm not going to go super depth into everything, but I've kind of labeled it from stuff I think is the most important at the top down to the bottom. So the number one thing I could possibly recommend is to just try and hack your own app. So go build your app, do it, upload it, do whatever, and then just re-download it and start hacking it from scratch. See where you can get, see what you can find. What can you manipulate? What can you change? How can you hack it? Look at the network requests. Are there things that are there that shouldn't be? This is the number one way to do it, because no one knows your app better than you do. And there's no one better trained to go through and try and hack the app than you. And on top of that, so other things you can do besides just that. So yeah, as I said, don't send anything to the app you don't want the user to see. Preferably use some obfuscator or ProGuard, even though this won't immediately fix all your problems. This is one of the easiest things you can do to make it way more difficult, because when all of the variables and all the method names are like random gibberish, at least you can't immediately go to the isProUser function and know, oh, this is the function to determine if user is pro. It requires you to do more digging and say, okay, I have method A, B, C, D, E. Like, okay, I have to go search through each one. What are they all doing? How do they work? And you might also be thinking, do I really need to worry about all of this? I just have a calculator app. Why do I care if anyone's hacking into my app? And you would be correct. So the amount of time you should spend on protecting your app should probably be directly related to the value someone would get out of hacking your app, right? So if you just have a simple solitaire game, a simple workout app, or something like the Drexel One app, where if someone gets into it and hacks it, it doesn't really matter to you. It's just contained on their own phone. If they want to hack the solitaire app and give them a high score for themselves, good for them. That's not really a problem. The problem starts getting up the chain when you start having apps that connect people together, have people interacting, and then you get up the chain to multiplayer games, things like Tinder, where you're just seeing other people's information and you want to make sure that's secure. You don't want other people to be able to find random people on these dating apps. You also have things like the Lutron app, right, where we're controlling actual devices in the real world. These new things need to be secure. We don't want other people being able to go through and control other people's devices. And then at the top here, you have things like banking apps, Venmo. Those are like the most valuable. If you find some vulnerability in the app that lets you access, and get some access to the server somewhere, that's like the holy grail. So, I'm sure they have way more security than the Drexel One app does. So I want to go ahead and show off some of these techniques on the Drexel One app. I thought this would be a fun thing to do. So I've gone ahead and tried to hack the Drexel One app, and I want to show off what I found here. So the first thing I want to show off, I don't know if you guys use the Drexel One app, but it has this function called the identification function, which basically lets you click a button and you can see your virtual ID. So here I'm not a student anymore, but I was still able to log in, so you can see, I have no picture and my name and whatever. But the thing about this isn't actually identifying or secure at all. This is just a picture and a text box next to it. Anyone can just change this to whatever they want. So I thought I'd show off how do we go about faking this and making our own identification for someone else. So we'll bring up the tool Flex, which would be a good place to start, and we'll run a class dump to get all the variables and methods that this view has. So I can immediately see a label for the name, the role in the university ID, and an image view for the photo. Pretty standard stuff. And I also here see a method called setIsLoading with a true or false value, which looks like a good place to might hook into to run some code. So now that we have this, let's go ahead and swizzle some code. So I've gone ahead and written this tweak, and basically all it does, as you can see, it says I want to hook into the Drexel app, and I want to hook into the ID view controller, and I want to hook into the function setIsLoading. And then if this method gets called and it's not loading anymore, I can just go in and say, I want to set the text role in university to this, and then I can load my own images and put them right into the app. And this basically lets me become whoever I want within the Drexel One app. So let's take a look at this running in real time. Alright. So this is my phone here, and as you can see here, I have the Drexel One app that I'll go ahead and open. And this is a perfectly normal Drexel One app, as if I had just downloaded it off the App Store. But I'll go ahead and open up the virtual ID function. And as you can see, I've inserted John Fry into the ID function. So as you see, you kind of make these changes. And because this was a change that I had made using code swizzling, this means I could then compile this change into the app and redistribute this modified Drexel One app to anyone else. And anyone else could use this modified Drexel One app themselves and change their ID and become whoever they want to. The next thing I want to talk about is the Drexel One API. So Drexel One has an API for their app, the Drexel One app, and this is used for a bunch of things. So it's a JSON API for the app, and once you sign in, it lets you access things about whoever signed in, like the schedules of whoever signed in, the grades, their co-op interview dates, meal plans, and dragon card balances, all this great information. And this is something that I know, especially while I was going to Drexel, everybody wanted access to this because everybody wants to make an app while they're at Drexel, and what better kind of app to make than something that uses the Drexel API, right? Making an app for people to find study groups together, making GPA calculators, making things for people to find Drexel events, or all sorts of detailed information. I know tons of people who wanted access, but it's a private API, and Drexel also doesn't like to acknowledge that it exists. I tried asking people while I was going there, like, who would I talk to about maybe trying to get access to this, or how would I officially do this, but everyone either said they didn't know what I was talking about, or I just never heard back. So I thought this might be a good example to show how I might go about reverse engineering an API like this. So the first thing we're going to do is we're just going to run this through the network inspector, because hopefully we can just watch the network traffic and see how are they making these API calls, and then we can just replicate it and make these API calls ourselves. So we open up Charles, I start sending my phone traffic through, and I log into the Drexel One app. The first thing I see is it connects to this API, and it sends this a post to this authentication method with my username, my password, and it goes ahead and it returns to me an authorization key. Now, what I was hoping was that I could just use this authorization key for the rest of my requests, and then this would allow me to just make requests, and that would be it. But I started looking around in the app, and every time the app would make a request, it would send this authorization header with this weird string that I wasn't quite sure what it is. So I tried making the request to the same place, to my grades, a few more times, and every time I made it, it generated a weird thing, and every time it was different. Which means it's not just using the authorization key, it's generating some sort of hash or something, we're not quite sure. So what is this string? Well, this is my user ID that I logged in with. This looks like some sort of timestamp, most likely it's the timestamp that was when I made the request, but this middle part, we don't really know. It's weird, it changes, there's no way for us to tell what's going on just by looking at this. So it's time to throw it into the decompiler. This is how we see how apps work and what the logic is. So we throw it in the decompiler, it poops out a whole bunch of Java files, and instead of just looking through them, we know that we're looking for a header for authorization. So we just searched the entire directory for the word authorization. A few things popped up, but one thing popped up that looked super promising. There was a class called data service that had a line that said, set header authorization to this value auth. So I'll go ahead and I'll open up the data service class, and I'll scroll down to where it said, and here I can immediately see this thing jumps out at me, and it looks exactly what we're looking for. So I'll go ahead and zoom in and kind of clean it up a bit. So this is exactly what we were looking at before. It looks like I have the username, colon, some sort of weird generate hash, and then the time at the end. So here what it's doing when it's generating the hash, it's calling this method, and it's passing in the authorization key that I got when I signed in, as well as the URL we're making the request to, as well as the current time. So we go ahead and we open up utils.generateHash, and we can see what it's doing. So I don't want to get too much into this, but basically what it's doing is it's generating a hash of the URL and the timestamp, and using your authorization key as a secret, and then encoding that entire thing into base 64 and returning that. So let's put it all together here. So first we make a request to the authorization API with our username and password. This returns to us an authorization key. Then we go to whatever URL we want to make a request to and append whatever the current time is in UTC. We then take the hmac-sha1 hash of that, using the auth key from the login as the secret, which kind of sounds complicated, but if you just look at Google how to do this, most programming languages can do this in like 4 lines. And you can just output that in base 64, and then you can just do what we did before. We can take my username, take the thing that it just generated, take that same time string that we put here, and send it as our authorization header, and there we go, profit. Now we have a working private API. So you might also be wondering, well, this URL here, this grades URL, what is that? Where do I find it? What URLs I can hit? What things I can get available? Well, Drexel is very handily decided to put all of the API routes together inside the strings resource file. So you can just go to the strings resource and just see an entire list of every API the Drexel One API supports. And then you can just go through here and make requests to these APIs for the course calendars and interviews and photos and all sorts of crazy things and athletic schedules. There's so much information here that I know would be so useful to so many students. So I went ahead and I wrote up that signature kind of code in Python, because I thought it was a lot easier to look at. But there's also a full paper and a working Python example of how to make requests on a Medium article I wrote. So I definitely recommend go checking that out afterwards if you're interested in kind of using this and seeing how it works. And so for the last part, now I want to start, we're going to have a reverse engineering challenge. So I made an app here, and basically all it is a password and a login button. And the first person who can tell me what the password is to this app won a Lutron plugin dinner. So you can go ahead and download this APK, you can or scan the QR code. There's a QR code in the link to the entire slide deck, so you can go back in, reference all my slides, go into the show notes and see, like, I have links to all the tools that I used, so you can kind of go back in and see those. I also, for this app, I left ProGuard off and I left debug mode on to hopefully make it slightly easier for you guys. And yeah, so for the rest of the time, I just kind of want you guys to start, if you're interested, start working on this. And I just kind of walk around and kind of help you guys out getting started, because I know a lot of these are brand new concepts and most of you probably have never heard of any of this. So yeah, I just kind of want to get you started, get your foot in the door. Things like this are extremely slow. I kind of just like breeze through all of these major points and all these crazy tools you can use, but learning how to use them, learning how to set them all up, doing all these things takes hours of time and experience. So it's not just like in one afternoon you become, you know, a mobile hacking expert. But that being said, I have tried to make this doable for beginners. You don't actually need an Android phone to complete this task. You can do it without one. I hope that's not giving too much away, but yeah, so I'll leave this up here. You guys can get started. And then, yeah, if you guys have questions, now would be a great time to ask any other questions you might have about mobile security or anything like that in general. I should have asked that before this, but cool. All right. Awesome. Thank you, guys.